Hello, students. Hope you had a wonderful day today so far. So let us see this question and try to solve it. A particle in equilibrium displaces from 112 meter, this is the coordinate, one coordinate, to 203 meter, another coordinate. If one of the forces acting on the particle is I minus j plus 3k Newton, total work done by remaining forces acting on the particle is how much? So suppose n number of forces are acting on that particle and one of the force value is given. So total force acting on the particle we can write like this. Remaining force plus one of the force that is given in the question. Let us notate it, the remaining force, like this: F subscript R. R stands for remaining. And one of the force as F1. Now from these two position vector, we can obtain the displacement. So what is your R1 as per question is 1 into I cap in the x direction. Number 2 is 1 into j cap in the y direction. 2 into k cap in the z direction. And your R2 is 2 into I cap. Zero into j cap plus 3 into k cap. Your particle is displacing from here to here, means from R1 to R2. So the displacement overall of the particle, if we notate it with delta S, will be R2 minus R1. So R2 minus R1 will be 2 minus 1 into I plus 0 minus 1 j cap plus 3 minus 2 k cap. That is I cap minus j cap plus k cap meter. So this is your displacement of the particle. In the question, it is mentioned particle is displacing in equilibrium all the time. Means displacement is so slow that we cannot associate velocity with it. So initial velocity when it was at R1 position, and finally when it is at R2, at both locations the velocity is zero. So from the work energy theorem, you can write total work done on the work done by the total force on the particle will be equal to change in kinetic energy. But at both locations, R1 and R2 position, velocity is zero, since the particle is displacing it in equilibrium as per question. So this will be your zero, is half mv v2 square minus half mv1 square. Both v2 and v1 is zero. And what is this wt? So now you can write, you know, from the work done by any force is total force dot displacement. What is your F total? F total is F remaining plus 1 of the force dot delta S. And this is your zero from work energy theorem. This, so your Fr dot delta S will be equal to minus F1 dot delta S. This is your work done by the remaining force Fr dot delta S. Just put the value of F1 and delta S. You will get the solution. How much is F1? F1 is given I minus J plus 3k Newton. I minus J cap plus 3k Newton. Dot, how much is your delta S? I cap minus J cap plus K cap meter. Expand this. So you will be getting I dot I1 minus J, that is become 1. 3k dot k is 3. So this is your minus 5 joule. Go back to question and check the option. So B is matching with our answer. the result which we got. So our answer will be option B. Hopefully you understood the way it has been solved. Still, if you have any doubt, please do write in the comment box. I will come back. Thank you.